This is a video lesson for Module 3, Lesson 6. The Lesson 6 learning target is I can multiply 2-digit multiples of 10 by 2-digit multiples of 10 with the area model. So we're actually going to be looking at a few different strategies of multiplying two-digit numbers by each other. Some of the strategies might look familiar, but we're going to be learning a new one today as well, the area model. So let's go ahead and jump into the first strategy we can use to solve these types of problems. So like the learning target said, we're going to be multiplying two two-digit numbers that are multiples of 10. So for the first problem, we're going to be solving 30 times 20. And I'm going to be showing how you can use a place value chart to multiply these two numbers by each other. I have two place value charts because I can actually solve this problem two different ways with the place value chart. So the first way that I'm going to solve this problem is I'm going to decompose the second number 20. So I'm going to actually look at this problem as 30 times 2 times 10. So I'm going to start by representing 30 with 3 tens discs on my place value chart. So I've done that. Next I'm going to multiply it by 2 because I decomposed 20 into 2 times 10. So to multiply these 3 tens by 2, I'm just going to double the amount of tens. So now I have 6 tens, so check. And then the last step I'm going to multiply by 10. And we know from our last few lessons that when we multiply something by 10, the place value discs get shifted one place value to the right. So that leaves me with my place value discs in the hundreds place. So I have 6 hundreds, 0 tens, and 0 ones. So I get an answer of 600 as my answer. Another way I can solve this problem is I can decompose the first number 30. So I can look at 30 as 3 times 10 and then multiply that by 20. I'm going to use the commutative property to rearrange these numbers so that it's a little easier for me to show this with the place value chart. I'm going to put 20 first, then I'm going to multiply it by 3, and then I'm going to multiply it by 10. So we have the same problem, just written in a different order. So now I'm going to start by representing 20 with 2 tens discs on the place value chart. Done that. Then I'm going to multiply by 3 by tripling the amount of tens discs. So now I have 6, so I've just multiplied it by 3. And then the last step I'm going to multiply by 10. So I'm going to take all of these tens discs and they're going to move over one place value when we multiply by 10. So those 6 tens become 600s. And I get the answer of 600 again, which makes sense because we are solving the exact same problem. So this place value chart method involves a little bit of decomposition. You start by representing one of the numbers, decompose the second number, and then you do 2 steps to multiply first by the single digit and then by 10. So that should look familiar from the last few lessons, just adding another step of, or not really adding another step, but just starting in the tens place versus the ones place as before. So the next strategy we're going to be looking at is a new strategy, which is the area model. And this is a really fun strategy to look at when we're solving problems like dealing with multiplication. So I'm going to be using the example of 40 times 20 and using the area model to solve this problem. When you look at the name of this strategy, area model, it might bring you back to a few lessons ago when we talked about area and perimeter with rectangles. And that should sound familiar because that's exactly what this strategy is. What we're going to do is we're going to create a rectangle that on one side has a length of 40 and the other side length is going to be 20. So I'm going to go ahead and represent that now. So I'm going to do 40 down, going up and down. So this is going to be worth 40. And this is going to be a length of 20. Actually, I'm going to move that 20 up just a little bit. So since both of these are multiples of 10, I'm going to split these into groups of 10. So I'm going to divide the top length here into 2 groups of 10. So that's going to be 10 and 10. And then on the side, I'm going to break it into 4 groups of 10 because I have 40. So I'm just doing my best to. So each one of these is worth 10. So 10 and 10 is 20 on the side, and then 10, 10, 10, 10 is 40 on this side. So now what I've done is I've created all of these small little squares inside of my big rectangle. And if I look at this top one right here, I'm going to look at this square in the top. I see that it's a 10 multiplied by 10, so it's got a width of 10 and a length of 10. So from my area model earlier, I know that I'm just going to multiply the side lengths together to equal the area. So each one of these little squares inside of here is actually equal to 100. So if I know that, I can kind of fill in the hundreds here because each one's 10 by 10. And I can just simply count the number of 100 squares I have inside. So I have 1, 2, 3, 4, 5, 6, 7, and 8. So I know I get my answer of 800. So using that area model, we're setting up the side lengths with the original problem of 40 and then 20. We're splitting it into tens because we know 10 times 10 is super easy to find. And then we're just counting the number of 100 squares on the inside. We can simplify this process a little bit, and I'm going to show how you could do that with the next problem, 50 times 40. So what we're going to do is we're going to set it up the same way. I'm going to create the long side length here of 50, and then I'm going to create the other side length here of 40. I'm trying my best to be as accurate as possible. Don't need to be exact, though. So I've got 40 on top. Then once again, I'm going to split it into sections of 10. So on the top, there's going to be 4 sections of 10, so 10, 10, 10, and 10. And then on the sides, it's going to be 5 sections of 10. I'm going to do my best to draw 5 somewhat equal sections of 10 here. Not too bad. 10, 10, 10, 10, 10. Now, since from our previous problem, we know that each one of these on the inside is going to be 100, we can see that we're essentially doing 1, 2, 3, 4 times 1, 2, 3, 4, 5 groups of 10. So we're essentially multiplying 4 times 5, which is 20, and then we're going to be multiplying 20 times 100 because each square is equal to 100. So I know there's 20 squares on the inside of this rectangle now, so I'm pretty much solving the problem of 20 times 10, which is going to be 2,000. If I wanted to double check my work, I could count up all the squares on the inside here by 100s. And if I did that, I would still get that same answer of 2,000. This more efficient version of the area model should look a little bit similar to the decomposition strategies we've been using the last couple days in class, particularly this portion right here where we're multiplying the lead digit in each number 4 times 5. Getting an answer, and then multiplying it by 100. So that's what the last strategy I'm going to show here is how we can solve these problems numerically with decomposing. So let's take a look at that exact same problem we just solved, 50 times 40. So with this problem, I'm going to decompose each one of these numbers here, and I'm going to separate the tens from the single digits that's being multiplied by the 10. So I'm going to represent the single digits with red, so I'm going to decompose it into 5 times 10, and then for 40 it's going to be 4 times 10. So now that I've decomposed both of these numbers here into 5 times 10 and 4 times 10, I'm going to use the commutative property to rearrange these numbers so that the single digits are next to each other and the tens are next to each other. So I'm going to have 5 times 4, and that's going to be multiplied by 10 times 10. So hopefully now you can see where we're heading with this. We're going to simply multiply 5 times 4 first, and then multiply 10 times 10 next. So 5 times 4 is equal to 20. And then we're going to be multiplying that by 10 times 10, which is equal to 100. And so you can see that we're back to the same problem we had a little bit earlier, 20 times 10, and that's going to be equal to 2,000. So we can use this decomposition to solve these multiplication problems dealing with 2-digit multiples of 10. I'm going to do one more example solving numerically. Let's go ahead and do 30 times 60. Once again, I'm going to use 2 different colors to represent decomposing the 1s and the 10s. So for 30, we're going to decompose that into 3 times 10. And we're going to be multiplying that by the decomposition of 60, which is 6 times 10. Using the commutative property again, so here remember that's the commutative property. I'm going to rearrange all these numbers that are multiplied by each other so that the single digits are next to each other. So this is going to be equal to 3 times 6, and that's going to be multiplied by 10 times 10. So after we do that, we're simply going to multiply our single digits and then our tens. So 3 times 6 is going to be 18. We're going to multiply that by 10 times 10, which is equal to 100. So we are going to find the answer by multiplying 18 times 100. And from our 10 strategy from last time and our 100 strategy from the previous lessons, we know that we are going to be shifting the 1 and the 8 2 place values to the left, which will add 2 zeros to our number, and we get an answer of 1,800. So there you have it, 3 different strategies that you can use to solve 2-digit multiples of 10 that are being multiplied by 2-digit multiples of 10. So at this point, you should be feeling pretty comfortable answering all the problems in the Lesson 6 problem set. But as always, if you get stuck, you can come back and rewatch any part of the lesson to give yourself a little bit of a refresher. So good luck with the problem set, and thanks for watching.